Amid the infinite expanse of cosmic wilderness, the Milky Way stands as our celestial sanctuary, a spiral galaxy teeming with hundreds of billions of stars, clusters of dark matter, and a colossal black hole at the helm. A typical galaxy in terms of size and stature within a galaxy group, it has unfolded and evolved in a serene dance across cosmic time. Unlike other galaxies that mature quickly only to lose the power to form new stars, or those that undergo colossal mergers and evolve into gas-free ellipticals. Our Milky Way, with its disk-like ensemble of stars ringed by globular clusters in a halo-like distribution, spiral arms that stretch out radially, and a central bar-like feature bulging with stars, paints a picture of an archetypal galaxy. The densest pockets of gas and dust in the galactic plane are a cradle for young stars. But galaxies like ours were once younger, bluer, smaller, and less spiral-like, evolving over billions of years through a process of attracting and merging with other galaxies. Starting from the first stars and star clusters, which quickly evolved and enriched the interstellar medium with heavy elements, to mergers of these clusters into full-fledged galaxies, the cosmos is a stage of constant evolution. And as the universe expands, the story of our beloved Milky Way takes a dramatic turn, gearing towards a monumental merger with the neighboring Andromeda galaxy. A fusion that will give birth to a new, larger galaxy, an event that's Brame discover. Oh, you'll soon discover. Hey there, Curiosity Explorers. It's your host Cesar again, ready for another deep dive into the unknown. And with me, as always, is the ever-vibrant and knowledgeable Sonia. Are you ready, Sonia?
Always ready, Caesar. Hi there, wonderful listeners. It's an absolute pleasure to be here, sharing this journey of discovery with all of you.
That's the spirit. Now, if you're enjoying our podcast, don't forget to subscribe to the Curiosity Wonderland, comment with your thoughts, and share us with your friends. Your participation really goes a long way in keeping us going. So, let's buckle up and get started. So, what was it like when our cosmic home, the Milky Way, was growing up? Well, it's a tale that's as fascinating as it is intricate. Our Milky Way is neither the largest nor smallest among galaxies, nor does it reside in some ultramassive cluster or isolation. No, the Milky Way is part of a modest galaxy group where it's the second largest member. But what makes it special is its evolution. Young galaxies are like raw clay mounds. Some mature quickly, exhaust their gas reserves, and end up as red and dead entities, losing the ability to give birth to new stars. Others undergo colossal mergers, often morphing from gas-rich spirals into gas-free ellipticals following these cosmic collisions. And then there are those that experience massive tidal disruptions, leading to stretched, sweeping spiral arms. But the Milky Way, it's like the middle child of the universe. It's grown up in a typical fashion. Imagine our galaxy as a pancake-like disk teeming with hundreds of billions of stars, ringed by globular clusters in a halo-like distribution. It stretches radially outward with spiral arms that span tens of thousands of light-years in a flocculent or multi-arm pattern. At its center, a bar-like feature emanates from a bulge of stars. Now picture a dense concentration of gas and dust in the galactic plane. This is the fertile ground where young stars are born, particularly along the density waves within the spiral arms. But the story doesn't end there. In fact, it's just getting started. Stay tuned, because what comes next is, well, you'll see. Let's flash back to the universe's beginnings. Imagine it, 13.8 billion years ago. The Big Bang had just happened, and the galaxies were forming. You look at the Milky Way now, and it's a massive spiral galaxy. But it wasn't always like this. Initially, it was much smaller, bluer, more chaotic, and richer in gas than what we see today.
So it wasn't born as a full-grown galaxy, but had to evolve into its present state.
Exactly. The galaxies we see today are essentially the result of cosmic evolution. Over billions of years, small proto-galaxies merged together, forming one larger-than-average galaxy. Our galaxy today is what remains after swallowing countless other galaxies.
Interesting. It's like the universe's version of survival of the fittest, huh?
You could say that, yes. Our Milky Way is an outcome of cosmic survival of the fittest. It is the accumulation of cosmic evolution, the merger of numerous smaller galaxies, all while attracting additional matter.
So our galaxy is like a cosmic cannibal, swallowing up smaller galaxies to grow and evolve?
Well, when you put it that way, yes. Our Milky Way is like a cosmic cannibal, but it's not as sinister as it sounds. This is just how cosmic evolution works. It's a process of building, akin to constructing a massive structure out of Legos. Only these Legos are changing form as we assemble the structure.
So it's like starting with 100 different X-Wing Lego fighters and ending up with a Star Destroyer?
A fun way to look at it, but yes, that's a good analogy. We can even survey the globular clusters within our galactic halo to learn more about this. Many of them have properties that suggest they joined the Milky Way at various points in cosmic history, evidence of these hierarchical mergers in our cosmic past. Now, it's not just about gobbling up other galaxies. Our Milky Way also experiences its own evolution. It rotates, forms stars, funnels matter towards the center, generates density waves along the spiral arms, attracts additional matter from outside along cosmic filaments, and changes shape and orientation based on the other galaxies and matter that falls into it. The journey from a proto-galaxy to the Milky Way we know today involved over 100 million years of star formation and evolution. The first stars, formed from pristine hydrogen and helium left over from the Big Bang, lived fast and died young, polluting the interstellar medium with heavy elements that gave rise to the second generation of stars. It's funny. All of this reminds me of a time when I was a kid, playing with my friends in the sand pit. We'd start piling up sand, each mound representing a star. Before we knew it, we had a whole galaxy built up. Of course, it wasn't nearly as complex as the real thing, but it's a memory that this talk of galactic evolution brings back.
That's a nice memory. You know what? It reminds me of a recent experience. I was baking a cake, and I realized that the process isn't so different from galaxy formation. You start with basic ingredients, mix them together, and then it evolves in the oven, growing and changing shape. It's a simple comparison, but it helped me understand that everything, even galaxies, has a process and a recipe.
As the universe continues to expand, gravity's pull stretches further, drawing in more matter that eventually merges with our galaxy. Smaller celestial bodies are tidally torn apart and slowly absorbed, creating an occurrence we call minor mergers. These minor mergers can even intensify star formation.
Could you give us an example of this minor merger?
Absolutely. Let's say there's a smaller galaxy falling into a larger one, like a pebble falling into a pond. The pebble doesn't disrupt the pond, instead, it's absorbed over time. This is similar to what happens in a minor merger. The smaller galaxy is drawn into the larger galaxy's interior, where its material gets absorbed over time. But as time goes on and the universe expands, major mergers become less common. Yet when they do happen, they're more significant. Major mergers occur when similarly sized galaxies collide, leading to severe increases in star formation.
Can you help me visualize this with another example?
Of course. Imagine two whirlpools in the ocean getting closer and closer. When they finally collide, their energy and force increase dramatically, creating one giant whirlpool. This is similar to a major merger of two galaxies. The collision results in a flurry of star formation, similar to the whirlpool's increased force. Even so, the majority of galaxies, including ours, exist in small groups, not in these massive clusters. After the first 4 or 5 billion years of cosmic history went by, it became clear that we'd never become part of a massive cluster like the Leo group, the M81 group, or the Virgo cluster. They're all beyond our reach. For our Milky Way to keep its spiral arms and ongoing star formation, it's important that any mergers remain small. Major mergers, where two similarly sized galaxies collide, can induce an enormous burst of star formation. But this event can use up a large amount of the available star-forming gas, expel the remaining gas, and mix up the stellar matter in the galaxy. Major mergers may result in the formation of giant elliptical galaxies, which are common in rich environments where major mergers frequently occur.
Can you give an example of a major merger?
Sure. Imagine two dancers spinning towards each other on a dance floor. If they're not careful, they might collide, causing a burst of energy but also disrupting their dance. Similarly, major mergers can consume and disrupt galaxies, causing a burst of star formation but potentially altering the structure of the galaxies involved. Our Milky Way has remained a disk galaxy with ongoing star formation, indicating that it hasn't experienced many, if any, major mergers in its past. If it had, we would see a large population of stars that all appeared to have formed at a specific time. However, our neighbor, Andromeda, does display such a population. This suggests that around 2 or 3 billion years ago, the third largest galaxy in the local group, behind Andromeda and the Milky Way, merged with Andromeda, making it the big sister galaxy we see today.
So major mergers are like a big dance-off, causing a lot of action but potentially upsetting the balance of the galaxy?
Exactly. Major mergers are significant events that can reshape galaxies. But even then, it takes a lot of mass, built up over time, to create a major merger. It's a cosmic dance that's been going on since the dawn of time. As long as a galaxy, like our Milky Way, is sizable and gas-rich, it will have the resources to keep forming new stars. And given that galaxies have a preferred rotation axis and enough time to settle into a stable shape, they will be likely to take on a spiral structure.
So it's like if the galaxy had enough building blocks and time, it will eventually construct a spiral shape?
Exactly. It's a cosmic construction project that happens over billions of years. Take, for example, the isolated galaxy MCG plus 01 to 015. It's thought to be the loneliest galaxy in the universe, but even it, despite being all by its lonesome for over 100 million light-years in all directions, is a massive spiral. Its features suggest that it formed from a series of minor mergers without experiencing any major mergers, and where star-forming activity has been relatively quiet for the past several billion years.
And what about our own Milky Way?
Our Milky Way likely grew from a series of proto-galaxies that settled into a spiral, then gradually absorbed many of the smaller galaxies in its vicinity. These smaller galaxies were once part of the local group, but they've been erased by what you might call galactic cannibalism.
So we're like a cosmic Pac-Man gobbling up other galaxies?
In a way, yes, but we didn't even consume the majority of those galaxies or matter in our local group. That honor goes to Andromeda. And we're not done yet. There are satellite galaxies merging with us today, and a few galaxies on our outskirts, like the 2 Magellanic Clouds, that will likely be devoured in the next few 100 million years.
So it's survival of the largest, not the fittest in the cosmic sense.
Exactly. In the cosmic story that brought the Milky Way into being, the objects with the greatest inertia and resistance to disruption survive. Mass is the overwhelming factor in determining what and who lasts the longest. In the beginning, clumps of matter form in a somewhat random asymmetric shape. Imagine a lumpy potato or a triaxial ellipsoid, which is a distribution of matter where one of the 3 3D axes is shorter than the other 2. As time passes, the shortest axis collapses first, causing the normal matter within it to pancake or go splat into a flat disc-like shape. This disc has angular momentum, and so it rotates.
So rotation is key in shaping galaxies?
Absolutely. As the disc rotates, structure within it, like spiral arms, begin to wind up. Over time, a disk galaxy's spiral arms become more pronounced and developed, accumulating more turns. Spurs emerge from these arms, and gravitational interactions both internally and from external influences lead to star formation along the tail ends of a galaxy. As more gas flows into the galaxy's outskirts, it heads toward the center. This inflow, and the continued evolution of the galaxy, lead to the development of many recognizable features we see in galaxies. A central bulge, a central bar that grows over time, and an even thinner disk as the galaxy compresses along the short axis and extends farther in the disk-like direction.
It sounds like galaxies are continually changing, evolving.
That's right. And eventually, all galaxies bound together within a group or cluster will merge. For instance, our Milky Way is destined to begin merging with Andromeda about 4 billion years from now. Another 3 billion years after that, the merger process is expected to reach completion, resulting in a new, larger galaxy that already has the rather poetic name of Andromeda.
That's a beautiful and somewhat melancholy thought, that our Milky Way will one day merge and become part of another galaxy.
Yes, it is. But remember, even though this process involves enormous scales and countless stars, only about 1 in 100 billion stars will collide or merge during this event. The final form of the galaxy is more likely to be a gas-rich, disk-possessing galaxy than the elliptical one typically depicted, as only a small percentage of major mergers lead to a gas-free elliptical final state. The cosmic story that led to the creation of our Milky Way has been a tale of constant evolution, but not necessarily ultraviolent. We likely originated from hundreds or even thousands of smaller, early-stage proto-galaxies that merged together. The spiral arms we observe today were likely created many times through interactions, only to reform due to the rotating, gas-rich nature of an evolving, gas-rich disk galaxy.
So it's a continuous process?
Yes, precisely. Star formation occurred inside in waves, often sparked by minor mergers or gravitational interactions, but also happening during quiet phases in our galaxy's life. This process is known as quiescent star formation. And these waves of star formation, as stars live and die, bring along increases in supernova rates, stellar cataclysms, and heavy metal enrichment of the interstellar medium. These changes don't happen all at once or abruptly, but rather gradually and continuously over billions of years.
And this process is ongoing?
Correct. It's not just a part of our cosmic past, but it's still happening. We can look forward to an incredibly spectacular conclusion just a few billion years in the future, as all the galaxies of the local group will eventually coalesce and merge together. Every single galaxy has its own unique cosmic story, and the Milky Way is just one typical example of a somewhat mature, larger than average, but not among the largest galaxies found within the universe. And remember, the story hasn't ended yet. As grown up as we are, the Milky Way, our cosmic home, is still evolving. Today, we've explored the grand cosmic story of our home, the Milky Way galaxy. From its humble beginnings as clumps of matter to the majestic spiral galaxy it is today, it's been a journey spanning billions of years. We've learned how galaxies evolve, grow, and eventually merge. We've seen how the Milky Way has survived and thrived as a disk galaxy with ongoing star formation, a sign of its resilience and occasional solitude in a universe characterized by change and transformation. But remember, while we've learned so much, this waltz of the stars is far from over. The Milky Way, like us, is still evolving, still changing, ready to meet its poetic destiny in the dance with Andromeda. That'll result in the birth of Milkdromeda. And in the face of such cosmic theater, I can't help but say, we may just be stardust in the grand scheme of things, but oh, what a magnificent dance it is.
So beautifully put. It's been an incredible journey exploring the life and times of our cosmic home. We're just passengers on this spaceship called Earth, cruising through the vast expanse of the universe, witnessing the constant evolution of everything around us. And on that note, folks, we hope you enjoyed this cosmic ride as much as we did. If you did, we'd love it if you could blast that like button and leave us a comment. Share this episode with your friends, your family, or even that random stranger who might just love a dose of cosmic knowledge.
Thank you so much for joining us today on this galactic journey. We truly appreciate your time and curiosity.
Yes, thanks for being with us. Stay curious, keep exploring, and until next time, goodbye from us.
Goodbye, everyone. I discovered this fascinating information from an article titled, "What Was It Like When the Milky Way Grew Up?" on the Big Think site. It was authored by Ethan Siegel and published on January 25th, 2024. The full URL is in the video description if you want to delve deeper into the subject, all right? Now, I'm off.